Okay, so Assalamualaikum warahmatullahi wabarakatuh and hi everyone. So first kali test mic dulu. Mic saya okay ke? Clear ke? Ada apa-apa masalah tak? Kot lah rasa macam bunyi kipas tu bising sangat ke apa ke. Oh by the way, kalian tengok dekat apa orang panggil yang kat depan tu muka sama tau. Cuma yang ni meletup sekejap. Sebab PKP so muka meletup sikit. Sabar je lah. Oh korang dengar lah, clear je lah aku cakap muka aku meletup. Oh my god. Okay, okay fine. Right, very good. Okay, so now I would like to remind you, please key in your attendance. So please go to the link that I give you. Please do make sure that the 8 o'clock is for our lecture and the 9 o'clock is for our tutorial. So please do make sure to go to the link that I send you first. So make sure to key in your attendance. Make sure everyone is here, no one absent. Sebab absent nanti kita kena kira ponting pak. So do make sure to key in your attendance first. I'll give you, I think around 1 minute for you to try. Oh wait, someone couldn't log in. Who's that? Let's see. Okay, never mind. If you couldn't log in, then never mind. I'll take the attendance later. I'll give you one link, or you can actually submit them later on channel, but never mind. We go through this one first and then I'll send you something for you to key in your attendance. Okay, let's see. There are around 40 of us. Never mind, let us start a little bit because I want to go a little bit slow today because you haven't learned maths for quite a while. So I guess we need to go a little bit slowly for the first class, of course. Okay, so now this is the first lecture out of 3. So altogether, I'm going to spend around 3 hours for the first chapter, number system. So we are going to learn about the real numbers, the complex numbers, and then we are going to do some recap on the rules of indices, and then the law of logarithm, and then one more, the rules of set. So we're going to see all those 3 things. Okay, so this is the first lecture. I think on Sunday we are going to learn the second lecture, and then another one on the next Wednesday, third lecture, and then we will finish chapter 1 and then we are going to proceed with chapter 2. So altogether in the first semester we have 10 chapters. Okay, so now let us move on. So what are the learning outcome for today? So this is just a little bit of recap. So you should be able to define the natural numbers, the whole numbers, the integers, the prime numbers, the rational numbers, as well as irrational numbers. So those are the set in the real numbers. And then you should be able to represent the rational and irrational numbers in decimal form. So we are going to see from decimal form how can we decide whether do we have irrational numbers or irrational numbers. And then C, represent the relationship of number set in a real number system diagrammatically, showing that the natural number is a proper subset of the whole number. The whole number is a proper subset of the integer. The integers are the proper subset of the rational numbers. So we're going to show them using diagram. And then, so we got to show that the rational numbers, when you unite with irrational numbers, you are going to get the real numbers. Okay, next. You should represent the open, close, and half open interval and their representation on the number line. Okay, so open interval, that means you're going to have this kind of bracket. So this is known as the open interval. The closed interval, you are going to get some square bracket. So those are the closed interval. Half open, it means that one of them must be closed, another one must be open. Okay, so you might have something like this, close, open, or open, close. So this is half open interval. So you should be able to represent them on the number line. And then we are going to do some union as well as intersection of two or more interval with the aid of number line. Okay, so I do see a lot of message coming from our Telegram channel. Never mind, I'll give you something later for you to key in your attendance. Don't worry, don't freak out. Keep calm, calm down. I'll give you something for you to key in your attendance. I'll do something with our channel. Wait a minute. Tunggulah sekejap, sabar. Okay, next Okay, so the real numbers. So this is the biggest number set that you have learned so far. We're gonna extend the idea later on. So this is real numbers. So we're gonna classify them into a few number set, which is the natural numbers, the whole numbers, the prime numbers, and then the integer, the rational numbers, as well as irrational numbers. So we're gonna classify them into these 6 number set. Okay, so what are the natural numbers? Natural numbers are actually the counting numbers. So the one that you learn during your kindergarten level. So masa kelas tadika dulu kan. Okay, so the numbers that you start to learn is 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. So those are known as the counting numbers or the natural numbers. Okay, so basically, from the set of those counting numbers, if you add 0 to them, it will become a new number set. So these are the natural numbers. You add them with 0, you're going to get a new set of numbers called the whole numbers. Okay, so whole numbers, you have 0, and then this 1, 2, 3 comes from the natural numbers. Okay, so what are the prime numbers? Prime numbers are natural numbers that are actually greater than 1 and can only be divided by itself and 1. So you don't see any other factor other than itself as well as 1. So the prime numbers, for example, are 2, 3, 5, 7. Okay, so let's see if we have a 9. 9 is not a prime numbers because 9 is actually 3 multiplied with 3. So we have another factor over here which is a 3. So that means 9 is not a prime numbers. Not a prime numbers. Oh, kesiannya ramainya yang mesej tak dapat. Tak boleh masuk. Sekejap saya masukkan ni lah. Okay, so saya dah masukkan So nanti buka dekat channel, tulis kat komen tu je, tak apa, nanti saya go through. Okay, so siapa yang tak dapat key in dekat website tu, tak apa, nanti awak masukkan saja dekat situ. Nanti bila saya tengok, saya akan ubahlah dekat website tu. Sabar semua orang. Okay, next. Right, so those are the natural, the whole, and the prime numbers. So next, we got something called the integers. Okay, so integers is actually the whole numbers plus with the negative of counting numbers. You see, this is the whole numbers. 0, 1, 2, 3. So those are the whole numbers. Negative 1, negative 2, negative 3, and so on. Those are the negative of counting numbers. Okay. Those negative numbers are known as the negative integers, where we normally denoted them with Z minus, and then those positive is known as the positive integers, where we normally denoted them with Z with a plus. Okay, next. Right, so now we're gonna extend the number set where we learned so far, which is integers. So we're gonna extend that idea into a rational numbers. So rational numbers are actually integers plus some types of numbers, which is a fraction and decimal. So what are the types of fraction and decimal that can be classified as a rational numbers? So dia macam tengah tengok banyak sangat mesej masuk kan, dia rasa macam pening sikit. Okay, next. Right, so if let's say we have a quotient or a ratio, then rational numbers is when you have a ratio or a quotient of two integers. So that means if you have a quotient or a ratio, both of them need to be an integer. So if we have A over B, both A and B need to be an integer, where B cannot be equal to 0, because otherwise we're gonna have 0 in our denominator, and that will make everything totally undefined. So if you have irrational numbers with a fraction A over B, then that means A over B need to become integers, where B cannot become 0. Okay, so if they are not integers, it will definitely become irrational. Okay, so irrational is that if you have A over B, they cannot be expressed as a quotient or ratio of two integers. So that means either one of A and B is not an integers. So salah satu lah, dia bukan integers. Quotient. Okay, next. If we have some decimal, how do we know, or how can we classify that some of the decimal are rational numbers? If we have a decimal, then it can be terminating or repeating decimal before we can classify them into rational numbers. If we have something that is not terminating or not repeating, we're going to classify them as irrational numbers. Okay, it's terminating, that means we will stop after a few decimal places. So for example, 1.2. So we actually stop after one decimal places. So that is what we mean by terminating. Okay, so what does it mean by repeating? Repeating is something like 1.2222. We're going to keep repeating the same number. So that is what we mean over here, repeating decimal. Okay, so non-terminating, it won't stop. So perhaps something that looks like 1.23 dot 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 dot, it keeps going on. It's not terminating, we won't stop. Non-repeating decimal, then it will be something like 0.3757 dot dot dot. So we don't repeat the same decimal or the same number. Okay, so let me give you some example. Okay, so for the first one, this is when you have a quotient. So it might looks like 4 over 7, 3 over 2, negative 1 over 3, 20 over 7, or even 3 over 1. So those are rational numbers. In decimal, you might have something like 1.5, negative 0.3 with a bar. Okay, so this one might be new for some of you. So if you have a bar, it simply means that we are going to keep repeating the same number. So this is negative 0.3 with a bar on top of the 3. So that means we are going to keep repeating the 3. So on. Indefinitely, maksudnya panjang lah. Okay, so the second one, the third one, sorry. So 0.571428, 571428, 571428. So it might not look that obvious to you, but you can actually see this number, they are actually repeating. So I repeat the same number actually. 571428, 571428, 571428. So this is actually repeating decimal. Okay, so what are the example for irrational numbers? Okay, so for example, pi over 4. So pi is not an integer, so that is why we cannot say it is a rational numbers. So e square over 3e is Euler number. So e is 2.71828 and so on. So those are not integer as well. So we're going to say that this is an irrational numbers. Okay, so set 3 over 5, again, that is not an integer. So since square root of 3 is not an integer, so we're going to say this is irrational numbers. Okay, so 1 over set 2. So set 2, again, that is not an integer. Therefore, this is irrational numbers. Okay, so now in decimal, you might have something like 0.123456789 dot dot dot. So we have this dot dot dot. It simply means it's not terminating. And as you can see, the numbers, we didn't repeat any decimal. So this is non-repeating, non-decimal. Non-repeating decimal, non-terminating. Okay, pi. Right, so pi is actually a well-known numbers that are not terminating. Okay, so this is an irrational numbers. The same goes with Euler numbers, so that is not terminating as well. So we're going to consider them as irrational numbers. Okay, so irrational numbers. Okay, so we can actually combine both of them together. So we can combine everything into one big set of numbers called the real numbers. Okay, so from this diagram, okay, so we start with the natural number. You add 0 to this natural number, you are going to get a new set of numbers called the whole numbers. So that is why we say that the natural number is a proper subset of the whole numbers. And then these whole numbers, you keep adding the negative of the counting numbers, it will become a new set of numbers called the integers. So that means the whole numbers are the proper subset of the integers. Okay, so now the integers you add with some types of fraction, some types of decimal, you're going to call them as rational numbers. So you're going to see them from the fraction as well as the decimal. So decimal need to be either repeating or terminating. So repeating, terminating. If we have a fraction, both of them need to be integers. Okay, if they are not classified as rational, it will definitely be irrational numbers. So as you can see, both of them are not in the same circle, they are separate things. So if we call them as rational number, it cannot be irrational. Irrational numbers cannot be rational numbers, they are two separate things. But if you combine them together, we are going to get a much bigger set of numbers called the real numbers. Okay, so that is what they mean over here. The rational numbers unite with irrational numbers, you are going to get the real numbers. Okay, so those are just a little bit of recap. Now, let's try to do this exercise. So I think I'll give you around 2 minutes for you to try this one. Meanwhile, I need to go through and see what happened, why we cannot key in the attendant and etc. So I'll give you 2 minutes starting from now until 8:20. Okay, so this is the question. Make sure to identify the natural numbers, whole numbers, integers, rational numbers, irrational numbers, as well as the real numbers. Okay, so give me 2 minutes for me to check first, okay? I'm guessing that perhaps since everyone trying to key in their attendance, so maybe dia jam sekejap lah kot. Tak apalah, kita bagi masa untuk dia cuba betulkan yang itu. Sementara tu siapa yang dah join channel tu jangan lupa key in dekat bawah tu lah, letak je kat komen. Nanti saya go through, saya akan highlight lah siapa yang ada, siapa yang tak ada. 1 more minute to go. How is it? Sempat ke nak dengar ke sibuk key in? Macam sibuk key in je. Okay, so it's already 8:20. So if you need more time, you can actually pause the video for a while before you try to do it. So those who have already finished, you can start answering these together with me. Okay, so we have -9 square root of 7, 1 over 3, pi square 0, 0.13 with a bar on top of 1, 3, 4, 5.1212. Identify the set of natural numbers. Okay, so natural numbers are actually the counting numbers. So from here, do check which are the counting numbers. So counting numbers tak boleh negative, so reject. Cannot be said, reject. So I only have one counting numbers, which is 4. So my natural numbers is actually 4. What about the whole numbers? So whole numbers is the natural numbers plus with 0. So you're going to see from the set of numbers, do you have 0? Yep. So our whole numbers are 0 and 4. So those are our whole numbers. So natural numbers plus 0. What about integers? So integers take everything in your whole numbers plus the negative of your counting numbers. Okay, so that means I can actually put -9 in the integers. So we have -9, 0, 4. So those are the integers. What about rational numbers? So rational numbers is actually integers plus some types of fraction and some types of decimal. If we have a fraction a over b, both a and b need to be integers. If we have decimal, then that means the decimal should either be terminating, so it will stop after a few decimal place, terminating or repeating. So if we can repeat the same number or we can stop after a few decimal place, those are the rational numbers. Sekejap opening pula. I'm just saying that in order to get a rational, you should take those integers plus with the fraction plus with the decimal. So it will be rational numbers. Okay, so what are the rational numbers? Okay, rational numbers, as you can see, you have those integer over here, -9, 0, 4. So I add some types of fraction where I have 1 over 3. Both of them are actually integers, so that is why I know this is a rational numbers. 0.13, so this is actually the case for a repeating decimal because we have a bar on top of 1 3. That means I'm gonna keep repeating the same number. 5.1212, as you can see, the decimal over here, I'm repeating the same decimal, so this is also a rational number. Okay, irrational number. Whatever that is not inside the rational numbers, those are irrational numbers. Okay, so I have -9. I don't have square root of 7. 1 over 3, yes. Pi square, no. Yes, 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 yes. So that means my irrational numbers are square root of 7 and pi square. So those are my irrational numbers. What about the real numbers? Okay, so as you can see, you can actually unite these two, the rational plus together with the irrational numbers, and everything will become the real numbers. To add everything together, those will become our real numbers. Is everyone okay so far? Are you okay? Ke tengah risau lagi tak boleh key in attendance? Don't worry, tak apa je, okay je. Nanti saya tengok. Okay, boleh. Siapa-siapa yang tak boleh follow nanti jangan lupa inform tau. Because normally sometimes when I get too excited, I did speak a little bit fast when I get excited. Excited dah ni nak ajar, ingat senang ke nak ajar. Best tau. Okay, next. Okay, Now, interval of numbers. So after we learn about the real numbers can actually be draw in interval of numbers. So kita boleh guna number line untuk real numbers. Okay, so there are a few things that you need to know or you need to understand. There are something called as the inequalities. Inequalities that mean less than, greater than, less than or equal to, greater than or equal to. So those are inequalities, ketaksamaan. Okay, so if we have include, so if we need to include the end point of the interval, so that means you have to make sure you you write down this line. So that line over there means that you are including your end point. If you don't want to include your end point, which means you want to exclude your end point, then you shouldn't write down the line. So it should either be greater than or less than only. So for example, over here, so x is greater than or equal to 1. So that means this one must be including. So we are including 1. X is less than 5. So we don't see any equal sign over here. So x excluding 5. We don't include 5 in our endpoint. So if you do have the line, it means include. You are going to include the number. If you don't have a line below here, that means we are not going to include the number. Okay, so what does it mean? It will give you totally different bracket. So if you need to include the endpoint, then you will have this kind of square bracket. If you don't include the endpoint, then you should use the open bracket or this kind of simple bracket. Okay, so what do they mean over here? You include the 1, you exclude the 5. So that is what they mean over here. So be extra careful, especially when we go to chapter 2. Either you wrote down the square bracket or a simple bracket. Those mean different things because we either include or we exclude the endpoint. So be extra careful. No, extra careful. Sama ada kita letak bracket macam mana tu. Be extra careful with that. Okay, so if you have a square bracket, so when you draw your number line, you're going to use a solid circle for them. Solid circle, that means for example over here, this one is a square at 1, right? So this is a dense circle or a solid circle. So bila kita lukis, kita kena lorekkan sikit lah. Okay, empty circle. So that one is normally for excluding the endpoint. So we're going to use an empty circle. So we're just going to draw the circle. So you don't have to dance the circle. Okay, so this is the number line 1 until 5. So a dense circle at 1 mean that we need to include 1. An empty circle at 5, that means we have to exclude 5. Okay, so now this is just a bit of recap. The symbol infinity indicate boundless. So that means if you have something like 1 to infinity, at infinity is always open bracket. So you cannot use a closed bracket to them because we cannot include infinity. Infinity is just a symbol. So every time you see infinity, it should be an open bracket. What if you don't use an open bracket? Then the answer is wrong, no marks. Same thing if you have negative infinity. So infinity, we need to use a open bracket. Okay, next. Right, so for the number, the interval number interval, okay, never mind. So for that interval, we can actually use union or intersection. So for union, it simply means that we are joining those two set of numbers. If we have intersection, that means we need to find the overlapping of those two set of numbers. So we're going to draw those two number interval and then we're going to find the union and intersection. So this one, we normally use them in chapter 2. So we're just going to do a bit of recap and then in chapter 2, we're going to use them. Okay, so now solve the following using the number line. So for the first one, you're going to do the union. For the second one, we are going to do the intersection. Okay, so union, intersection. Okay, so let me do the first one. So we have 0, 5, 4, 7. So the first thing that you should do is that you need to draw a number line and make sure you have everything in ascending order. So the negative numbers should be on the left, 0, the positive number should be on the right. Everything need to be in ascending order. Okay, so let me show you how. Okay, so this is my number line. So I have 0, 4, 5, 7. So just simply draw a line, make sure everything is in ascending order. Okay, and then see on the left hand side, you have 0 up until 5. So make sure to draw a circle on 0 and then draw a circle on 5. But for 0, we need to use a dense circle. And then make sure to connect those two circles. Okay, so this is 0, 5. Biasanya kalau kalau dah biasa buat, saya tak minta dah lah tulis yang sebelah kanan ni tau. Yang ni just to show you. Okay, so this is 0, 5. Okay, so we have a dense circle at 0, an empty circle at 5, and then another one 4 until 7. So both of them, you need to see an empty circle because both of them give you open interval. Okay, so now what do we need to do? We have union. So union, that means you have to join those two set of numbers. Okay, so we're going to join everything together. Okay, so join the area. So what do you have is 0 up until 7. Okay, so be extra careful. At 0 over here, as you can see, this is a dense circle. So that is why you have a square bracket at 0. At 7, those are an empty circle. So that is why you have a simple bracket. Okay, so those are what we mean by joining the area together. So do the union. Okay, so how do we do the intersection? Okay, so again, you need to draw a number line. Make sure to write down everything in ascending order. Okay, so I have -1, 5, 9. So infinity, don't write them down on your interval. Infinity dia tak ada dalam interval Dia tak ada dalam nombor yang kat bawah tu. Okay, so negative infinity to 5, what do they mean is that if I draw my number line, it will be 5 and going indefinitely to the left because we are going to negative infinity. So draw a circle at 5 going indefinitely to the left. So this is negative infinity until 5. And then of course an empty circle at 5 because this is an open interval. Okay, another one, -1 up until 9. So a dense circle at -1, an empty circle at 9. So that is -1, 9. Okay, so now find out the intersection of those two number line. To find the overlapping area, so it does overlap from -1 up until 5. So at -1, so this is a dense circle, so do make sure you need to use a square bracket for them. At 5, this is an empty circle, so make sure to use a simple bracket for them. Okay, so the answer for them is -1 up until 5, including -1, excluding 5. So those are how we use the union and intersection. Okay, so if you still couldn't understand this, please make sure to revise a lot more. We are definitely going to use this in chapter 2. Again, I put more emphasis. We're going to use them in chapter 2. Okay, so now I'm going to start with a much more bigger set of numbers called the complex numbers. So before this, you learn about the natural numbers, the whole numbers, the rational numbers, irrational numbers. So you do have something called the real numbers, right? So this is the real numbers. But we actually have a much more bigger set. So, buka besar sikit. This is known as the complex numbers. So we can extend our idea a little bit into complex numbers. Okay, so in complex numbers, you should represent them in Cartesian form. So what does it mean by Cartesian form? That means you should be able to write down the z. So this is the complex number. Z represent the complex number. You should be able to write down z as a plus bi. So if you can write down z equal to a plus bi, so a and b are some numbers. Okay, so if you can write them down as a plus bi, so this is actually Cartesian form. Okay, and then define the equality of two complex numbers. So that means if I have one complex number on the left, one complex number on the right, so how to define the equality? So that means the real number on the left equal to the real number on the right, imaginary number on the left equal to imaginary number on the right. So we're going to see them later on. And then show the conjugate of complex number. So if we have a complex number z, then the conjugate of the complex number is normally denoted with z bar, or some people might write them down as z with an asterisk. So those are actually the conjugate of z. So you should be able to know how to find the conjugate of a complex number as well. So Cartesian form, equality of complex number, and then the conjugate of complex numbers. Okay, so now introduction to complex numbers. So why do we need to extend the idea into complex number? This is because certain equations in maths, when we solve them, we are not going to get any real root. So for example, if let's say you want to solve x squared plus 1 equal to 0, then that means x squared is equal to -1. So if I want to solve to get x, or if I want to find x, then x will be plus or minus square root of -1. So in order to get rid of the square, so this is a square, kuasa 2 tu kita panggil square. Square, in order to get rid of the square, we have to apply square root. So that is how it become the square root of -1. So why do we have plus and minus? So basically, if you have an even power, for example, x to the power of 2, x to the power of 4, or x to the power of 6, you have an even power, when you are taking the root of it, you should use plus and minus. Okay, so this is x squared equal to -1. So it is an even power. So that is why x is equal to plus or minus square root of -1. So if you think a little bit, basically when we learn our real numbers, we don't see anything like this. We never see something like square root of -1 before. So that means when it comes to real number, we are going to say we don't have any solution. So we don't know the solution for this. So basically, in matriculation, we have to extend that idea a little bit. So if in high school, you don't have the solution for them, in matriculation, we actually have the solution for them, which is called the complex numbers. Okay, so if we, let's say, take the I equal to square root of -1, then that means we do have some kind of solution now, which is x equal to I or x equal to -I. So those are the imaginary numbers. So the imaginary unit I helps to solve equation with no real root. If you cannot find any real root, you are going to use imaginary numbers. So now whatever kind of question we get, we definitely going to get some solution. So dah tak keluar dalam macam, oh tak ada solution, tak ada solution. No, you are going to get some solution, but it is a complex numbers. Okay, next. The imaginary unit, normally we gonna see some I. So kalau nampak I tu, itu adalah imaginary unit. So we can actually express the square root of any negative numbers as a real multiple of I. So for example, if you have the square root of -16, you can actually separate to become square root of -1, multiply with square root of 16. If you see multiplication inside the square root, you can actually separate the square root into two independent square root. So we can have square root of -1 multiply with square root of 16. And then square root of 16, as you know, that is a square number which is 4. Okay, so square root of -1, we're going to denote them as I. So we are going to get I, square root of 16, we're going to simplify them. So it will become 4. So I times with 4. Therefore, the answer to this is 4I. I. So we can actually express the square root of any negative numbers as I. Kenapa Daniel tiba-tiba test mic ke? Okay. Right. So actually, the power of I can be simplified. So that means if you have any complex number, the highest power of I should be 1 actually. So A plus BI. So Z is equal to A plus BI. So we don't see anything with I square or I cube or even I to the power of 4 and so on. Why is that? That is because if we have I square, we can simplify them to become -1. If we have I cube, we can simplify them to become -I. If we have I to the power of 4, we can actually simplify them to become 1. So that means the highest power of your complex number can only be I to the power of 1. So if let's say you multiply them or you do some division and so on, and somehow you end up with I to the power of something other than 1. So what do you need to do is actually simplify it. So from I square, change it to -1. If you have I cube, change it to -I. If you have I to the power of 4, change it to 1. So now you can simplify them into Cartesian form. So kita nak simplify ni sebab nak dapat Cartesian tau. Cartesian tu A plus BI. Dia kena I kuasa 1 saja. So that's the reason why. Attendance siapa kutip? Saya lah. Siapa lagi? Boleh pula tanya macam tu. Okay, so now complex number in Cartesian form. The complex number z equal to x plus yi consists of two parts. So in complex number, we have two parts. We have the real parts and then we have the imaginary parts. So how do you know which one is the real part and which one is the imaginary part? So like the name itself, imaginary, so that means you should have some term with I. So term with an I, those are imaginary part. Those without the I, those are the real part. Okay, so for example, if z is equal to 2 plus 3i, as you can see, 2, we don't have any I, so those are the real number. 3i, we have some imaginary numbers, so the imaginary is 3. If z is equal to 5 minus 2i, then the real part is 5. The imaginary part is -2. Okay, so those with I, those are the imaginary part. Those without the I, that one will become the real part. So real part plus imaginary part, both of them is the complex numbers. Okay, so two complex numbers, z1 and z2, are said to be equal if the real part on the left hand side is equal to the real part on the right hand side. So the imaginary part on the left hand side need to be equal to the imaginary part on the right hand side. So if let's say we have a plus bi and equal to 3 plus 2i, right? So this is the real part. This is the real part. They need to be equal because you have the equal sign over here. So a need to be equal to 3. If you have bi and 2i, so those are the I, that means b must be equal to 2. Or I actually wrote them down over here. Tiba-tiba je tak nampak, sabar je lah. So m plus ni is equal to 3 plus 2i. So you compare, this is the real part. So m is equal to 3. Compare the imaginary part. So n is equal to 2. Okay. Those are the idea for equality of two complex numbers. Okay, so I think better for us to try this example. Okay. Tarik nafas, hembus, tarik nafas, hembus. Okay, sikit lagi. Nak habis dah. Sikit lagi. Okay, so now find A and B for the following equation. So I think I'm gonna do A. For B, I'll left that to you. So try them on your own. I'll give you some idea. Okay, so A plus B plus A minus BI is actually equal to 6 plus 4i. Okay, so we do see this equal number over here. So that means the real number on the left hand side will be equal to the real number on the right hand side. So make sure you separate who's the real number, who's the imaginary number. Okay, So this one, those are something without the I. So that is actually the real numbers. A minus bi, so we do see something that is multiplied with I, so that is the imaginary part. So this is the real part, imaginary part. 6 plus 4i, I don't see any I over here, so 6 is the real number. For I, so we have I, that is definitely imaginary. So since we do see the equal sign, it simply means that the real part on the left need to be equal to the real part on the right. The imaginary part on the left will be equal to the imaginary part on the right. So that means we can obtain two equations. Okay, the first one, a plus b is equal to 6. So this is when I compare by comparing the real part with the real part. So I compare the real part, a plus b is equal to 6, and that one will become the first equation. And then I compare for the imaginary numbers. So I have a minus b, and the imaginary number on the right hand side is actually 4. So we have the first equation, the second equation. So how are we going to solve them? So a plus b equal to 6, a minus b equal to 4. So you can use two methods. You can either use the substitution method or elimination method. So this is simultaneous equation, persamaan serentak. So in simultaneous equation, you can use substitution or you can use elimination method. Okay, so I'm using some elimination method where I take the first equation, I minus them with the second equation. So when I minus them, A will be minus with A, so I left with 0. And then B minus minus B, so it will become B plus B, so that one will become 2B. And then 6 minus 4, so it will become 2. So what do I have left is 2b equal to 2. So that means b must be equal to 1. Okay, so once you know the value of b, you can either go back to the first equation or the second equation, substitute the value of b, and you can find out what is the value of a. Okay, so substitute, a will be equal to 5. Okay, so far, okay? Is everyone okay with this? Okay, kau penat dah? Okay ke? Kau penat dah? So far masih bernafas macam biasa? Okay. Okay, okay. Ada juga tersekat medium. Bolehlah medium lah. Sabar je lah. Boleh So saya move on Okay, so now part B. Okay, so part B, we have A plus 2B plus A minus B I equal to 9. Boleh lagi nafas. Sabar je lah. Okay, so now we do see those equal signs. So that means you're going to compare the left hand side and right hand side. So the real part on the left, real part on the right, imaginary part on the left, imaginary part on the right. Okay, so I don't see any I with A plus 2B. So this is definitely the real part. A minus BI. So this one times with I. So this is the imaginary part. Okay, so now over here, I only have one number, which is 9. So I don't see any I over here. So that means this is definitely the real part. We don't see anything with I, right? So if we don't see anything with I, that means this is plus 0 I. So letaklah untuk memudahkan plus 0i. So this is our imaginary numbers. Okay, so you're going to compare the real part, imaginary with imaginary. So you will come out with two equations. The first one is a plus 2b equal to 9. The second one is a minus b equal to 0. So you will have the first equation where you compare the real part, the second equation where you compare the imaginary part. Okay, and then you're going to solve them simultaneously. Again, either elimination or you can use substitution, either one. So solve them. Yang ni saya laju sikit lah. Cuba. So you're going to get the value for B is equal to 3. The value of A is also equal to 3. Okay, so just write down A equal to 3, B equal to 3. Try them on your own. If you have any problem, do let me know, okay? Right, next. Right, so now in complex numbers, we can actually do some algebraic operations. So what do we mean by algebraic operation? It means that we can do some addition, we can do some subtraction, we can do some multiplication as well as division, something called as division. Okay, so we can do those algebraic operation. Okay, so addition, subtraction, or multiplication, we actually solve them the same way as in polynomial. So we're gonna add them the same way as in polynomial. So I with I, numbers with numbers. So the same way. Macam awak buat polynomial X with X, Y with Y, right? But this time we have something called the I. So numbers only with numbers, and then I with I. Real with real, real with real, imaginary with imaginary. But if you have multiplication, somehow you will end up with I times with I. Therefore, you need to use the definition where I square is actually equal to negative 1. Okay, so if you don't have your note, please highlight. If you have your note, please highlight this part. If you don't have your note, please write them down very big. I square is equal to negative 1. We're going to use them later on. So I square equal to negative 1. I square negative 1. I square equal to negative 1. I square equal to negative 1. So, Miss tengah psycho sekejap bagi hafal. I square is negative 1. Okay, next. Addition, subtraction, multiplication. Okay, so now given that Z is 4 plus 3i, W is 7 plus 5, 7 plus 5i, find Z plus W and then Z times with W. Okay, so I'm going to do the addition first. Okay, so we got 4 plus 3i plus 7 plus with 5i. Okay, so what we will do is that we're going to add the real numbers with the real numbers, the imaginary with the imaginary. So we're going to see that this is the real, that is the real. So we're going to add them together. So 4 plus with 7, which is 11. And then 3i you plus with 5i, so it will become 8i. So 4 plus with 7, 3 plus with 5. So we are going to get 11 plus 8i. So those are how we do the addition. So you simply add the I with I, those without the I with those without the I. Okay, what happened if we have multiplication? Okay, so for example, we have Z multiply with W. So 4 plus 3i multiply with 7 plus 5i. So what do we need to do? We need to expand them. So open the bracket, make sure to open the bracket, expand them. So multiply them one by one. So 4 times with 7, so expand them, and then 4 times with 5i. So once you're done with that, make sure you do 3i times with 7 and then 3i times with 5i. So do it one by one. So altogether, you should have 4 terms. So 4i times with 7, that is 28. 4 times with 5i, so that is 20i. 3i times with 7, 20i. 3i times with 5i, that one will become 15i square. So this is when you have something that is higher than I to the power of 1. Therefore, you need to simplify them. Just like yang tadi saya psychokan tu tadi, apa dia? I square equal to negative 1. Very good. Okay, so 28 plus 20i plus 21i plus 15i square. And then we have to change I square to become negative 1. So that means we are going to get 15 multiply with negative 1, which will become negative 15. Okay, so you're going to add this imaginary number together. So they will become 41i. So 28 plus 41i minus 15. So simplify, those are the real numbers. The real numbers, simplify them together, 28 minus with 15. So it will become 13. So we are going to get 13 plus 41i. So this is in Cartesian form. Sebab I yang paling tinggi adalah I yang kuasa 1. So this is in Cartesian form already. Okay, so those are multiplication. So we can do addition, we can do subtraction, we can do multiplication. But when we do multiplication, do keep in mind that if you have I to the power of something other than I to the power of 1, you need to simplify them. So if you do end up with I square, I cube, or I to the power of 4 and so on, please simplify. Okay, next. We only have another 2 example. Hopefully you are doing well. Okay, so now conjugate of a complex number. If we have a plus bi is actually the conjugate of a minus bi. So if you have a minus bi, that is the conjugate of a plus bi. Okay, so what does it mean with the conjugate? So conjugate is actually the uh, reflection along the real axis, yang pasti X tu kan bila kita reflect. So those are actually the reflection. But in a simple way, we're gonna say that this is what happened when you change the sign of your imaginary part. Okay, so A is the real part, BI is the imaginary part. Do you see over here? From a plus, it will become a minus. So only change the sign of the imaginary part. Highlight a little bit, okay? So this is imaginary part. Only change the sign for the imaginary part. A plus A minus BI. So this one, instead of minus BI, it will become plus BI. So we're going to change the sign for the imaginary part. Okay, if let's say you have 4 minus 3i, then the conjugate for that is 4 plus 3i. If you have negative 2 plus 5i, the conjugate is negative 2, negative 5i. So do keep in mind, this is the real number. Don't change the sign of the real number, okay? We only change the sign of the imaginary number. So keep the real number, only change the sign of the imaginary number. Okay, so the conjugate of the complex number is also denoted by Z bar. So if you see some question involving complex number and you see those bar, itu bukan fraction lah. Z bar is actually the conjugate. So kadang-kadang saya kira, oh tersalah tulis fraction, tak ada fraction. No, 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 it's not a fraction. It is actually the conjugate. Or you can actually write them down as Z with asterisk. Asterisk pun boleh jugalah, atau tak nak letak bar, biasanya letak asterisk. Kalau saya suka asterisk sebab cantik sikit. Okay, next. Multiplication of conjugate give a real number. So for example, if let's say I have A plus BI, I times with its conjugate, what do you see is that you're going to get A square plus B square. So I don't see anything with I. So that means if you multiply the Z together with its conjugate, you are supposed to get some real numbers. Okay, so division by a complex numbers. So both the numerator and denominator are multiplied with the conjugate of denominator. So now the denominator is a real number. So if you have something that looks like this, Z1 over Z2, and then what you need to do is take the conjugate of this denominator. So this is called as denominator. The one at the top is the numerator. The one at the bottom is the denominator. So numerator, sebab ada yang belajar bahasa Melayu kan, so saya bagi sikit lah. Numerator, denominator. Okay, numerator is at the top, denominator is at the bottom. Okay, so what do you need to do is that you have to multiply with the conjugate of the denominator. So see your denominator. The denominator is Z2, so the conjugate for them is Z2 bar. So we're going to multiply with Z2 bar over Z2 bar. Okay, so when we times them, Z1 times Z2 times with Z2 bar, so yang ni bila darab dia akan dapat real numbers. Okay, why do we need to learn this? That is because most of the time we have to simplify the complex expression. So for example, 3 over 1 plus I. Okay, so I'll do A. Meanwhile, you guys can do B. Okay, so now A, 3 over 1 plus I. So mathematician, there are two things that we hate the most in this world. The first one is that we don't like having I at the bottom, which is the denominator. So we don't have, you cannot have I. in your denominator. The second one, you cannot have Z in your denominator. If you have either I or Z in your denominator, you have to simplify your expression, or you have to do something called rationalize your denominator. Tukarkan nombor yang bawah tu kepada rational, because those are the thing that we hate most. We don't want imaginary numbers or even Z in our denominator. Okay, so how do we simplify? Okay, so this is something that looks like a fraction. Therefore, I have to times with the conjugate of my denominator. Okay, so my denominator is 1 plus I. So the conjugate of them is 1 minus I over 1 minus I. Okay, so make sure you times them. 3 times 1, 3 times negative I. And then expand your denominator as well, of course. 1 times with 1 times with negative I times 1, I times with negative I. So expand them very carefully. What are you going to get is 3 minus 3I over 1 plus I minus I square. So now, when you do multiplication, you do end up with I that is higher than I to the power of 1. So simplify. What do you know about I square? Again, keluar benda yang saya suruh hafal tadi. Apa? I square is equal to negative 1. Okay, so change it. I square is equal to negative 1. Okay, so I minus I, those two are the same thing. So I cancel out those two, okay? So 3 minus 3I over 1 minus. So I change I square to become negative 1. So now I have 1 plus 1. So I have 3 minus 3I over 2. In order to write them down in Cartesian form, you have to separate them. So it will become 3 over 2 minus 3 over 2 I. So those are already in the simplified form. So ini dah cantik lah. Kenapa cantik? Sebab dah tak ada I dekat bahagian bawah dah. I tu duduk kat sebelah dah. Akilah Murshida. Bagus. You do remember benda yang saya psycho tadi. I square equal to negative 1. Okay. Now, what do we need to do? Okay, so it's already 9 o'clock. So I'll give you 5 minutes to take a break. Okay, so after this, nanti dalam Telegram group, so kita akan discuss lah solution untuk yang ni. Kita tengok macam mana. Ada masalah tak? Kita check jawapan sama-sama. And then please try to do question number 7 as well. So untuk siapa yang tak ada soalan, tak sempat salin soalan, so salin dulu yang ni. 4 plus 7i over 2 plus 5i. So those are the first question. The second question, ada solution tak Cik? Okay. Z is 1 minus 2i. Express Z plus 1 over Z in the form of A plus BI. Okay, so this one, tulis Z kat sini, tulis Z kat sini, and then cuba tukarkan dia dalam bentuk A plus BI. Okay, so I think that's all for the lecture. I'll see you guys in the Telegram group. So nanti kita tengoklah dalam Telegram. Kita akan discuss dalam Telegram sekejap lagi. Okay, so thank you everyone. Have a nice day. Bye-bye.